It's funny how when you work for yourself, time just disappears. You blitz weeks. It's only week 5. I don't know where that time's gone. It's just weird how, just the way it is. There's never enough hours in a day when you work for yourself. But yeah, we'll get on and get as much done as we can. Morning all, how are you doing? It's week 5 already, and I've been down to Howard's and given them a hand with a few jobs. Mum and Dad's and Howard's are next door to each other, and the workshop's at Mum and Dad's. There's 300-foot difference, and that difference is the difference between us having sunshine and them not. So that's looking up Wensleydale, and those trees in the bottom just there weren't there a couple of minutes ago. It's funny how fast it's clearing. So we've got quite a bit going on this week. I'm aware I keep talking about Lactalign and I haven't really explained it, so I'll explain Lactalign. This morning I'm going to be in the office. I've got jobs to do for shows that are next year and sending emails for ordering laser cut stainless steel parts and mild steel parts for different jobs, some for Lactalign, some for other stuff. So that's this morning's job, and then down to the workshop this afternoon and get some jobs done down there. And before you know it, that'll be Monday done. It's funny how when you work for yourself, time just disappears. You blitz weeks. It's only week 5. I don't know where that time's gone. It's just weird how, just the way it is. There's never enough hours in a day when you work for yourself. But yeah, we'll get on and get as much done as we can. This is Lactalign. This is a device for balancing the weight of a milking cluster when it's on a cow. So when you've got a cluster on a cow, there's the pipes that come off it, and that means the weight isn't even over the 4 quarters. So this supports the weight of the pipes, and that then means that it reduces things like liner slip, reattachments, and we've also shown that it's reduced case of mastitis if you've got a bias one way or the other. So this is the one that goes on a rapid exit, so that's for a Bowmatic rapid exit. So it sits on the curb, slides up and down, so that when the cows aren't just in the centre of the bale, you can move it to put it in the right place. This is something that has been developed in the last 2 years it's a collaboration between me and Philip Metcalf up at Washfold at Laban. They've been in at Washfold since the 28th of December 2020, and it's had a massive impact on mastitis up there. On the 25th of November this month, collectively it had done 5 million milkings on the 4 farms it's fitted. My earlier smuggery about being in the sunshine didn't last long, so now we are surrounded in mist. Anyway, I've been doing office work this morning, so I'll quickly show you what I've been on with. I have a thing called a 3DCONNEXIONS mouse, which that is a 3DCONNEXIONS mouse, which is pretty cool. I'll try and make it so you can see both at the same time, like that, something like that. Is it both in? Just about. Right, so anyway, if I turn this, it moves that, whichever way I turn it. If I go pull it up, it zooms out, push it in, it zooms in. Return it, it turns around. It's cool. And it's got loads of other buttons on it as well. All these other buttons do different jobs, so I set these ones here to do different jobs. These ones here do different jobs. I don't really use these ones here, but anyway, it is so much. It was very expensive, but it saves so much time, because if you're just running Solidworks with a mouse, even a mouse, this goes with that, and it has more buttons on than most mouse, and it does different things. But normally when you're running a Solidworks with just a normal 2-button mouse, you have to do all that moving with the mouse, and that's where it saves so much time, because changing things around, zooming in and out with that. So when I'm running the Solidworks, I've got one hand on here like that, doing that, moving it, doing everything. and I've got my other hand on here moving the mouse. So that is how I operate Solidworks, and this is a sheet metal part. So this is a folded part that if you turn it like that, you can see it's got 2 bends in it. So Solidworks, I'll just try and hold you a bit better. Solidworks sheet metal flatten. So that then is the flat version of that part, and that line there and that line there are the bend lines. So what I do when I need to create, and I'm not saying this is the way everybody does it, this is just the way I do it. If there's a faster way, I'd love to know, because it's very tedious. So that's how I create a flat pattern of the drawing. That I then send to the laser cutters. So that is the flat pattern. So that's a DXF file that the laser cutter can then use to put it in the laser cutter and tell the laser cutter exactly what it wants to cut out. And that those 2 dashed lines are the bend lines. So yeah, and then so I fold it again. There. So it's back to the normal shape. So I then upload all those files onto an email and tell them how many we want, what material, thickness. So all those files there are all the files to do with Lactalign. So it takes me quite a while to do all that work, just because getting it right, and I don't always get it right. Normally I've forgotten something, or I haven't changed the material type to stainless steel on the drawing. There's normally some sort of error, and it can be quite annoying and tedious, but that's what I've been busy with this morning. And I've got to do the same again for a load of mild steel parts that I need to get ordered from another laser cutters. I use 2 or 3 for different jobs, because they all sort of seem to specialise in certain materials and certain types of work, and so they'll be keener on a price for the work they want as compared to if it was a work they didn't want. So yeah, and also I don't always buy on price. I do buy on quality as well, because it sort of pays off to just, the quality can make, if you don't pay for the quality, you pay for it by having to alter the part, even though it's been sent in the same format to 1 or 2 different people. There can be a slight difference. So yeah, I'll carry on doing this, and it'll soon, well, it's lunchtime now actually, so probably get my lunch soon. So yeah, right, bye. Morning all, how are you doing? Just on with some more Solidworks jobs. So this is one of the compact front boxes, and each of these is an individual part. So that's a part separate to that part. So all these different bits down here make up the different components. And just thought I'd show you this. So the laser cut parts are parts like that part there and that part there. So that's an individual part, and we go into it and open it. So that's what it looks like. And so then I generate a DXF file from that then gets sent to the laser cutters, and a drawing with the dimensions on. And to give you an idea, that's what we get back. So that's been laser cut. You can sort of see on the edges there where there's like lines, that's how it's been laser cut. You can see here where the heat's distorted the metal a little bit on this side. So that'll be the cut side, and then that's the back side. So it's very accurate. That's why we sort of prefer to use laser rather than plasma. Plasma's good enough, but we tend to use laser really, just because you get holes like that are dead right. So yeah, I'll getting another laser order sorted out, email to the laser cutters, and we'll get some more bits coming in. Just taking my space heater for a ride out to get it refilled, so we're not freezing in the workshop. This is a random Saturday afternoon project. It's a rack for the offcuts of steel to make best use of them and easy to find, and save me storing short lengths that just end up hoarding, and also can move it with a battery powered forklift. I'm going to give this a go, see if it works.